Thank you. That's very nice and short. I guess, first of all, good afternoon, everyone. And thank you guys for coming to this talk around how do we build observability into serverless applications. So I want to start by going back a bit on history. So back in the Second World War, the Allied forces had a problem whereby their bombers just keep getting shot down by those German artilleries. And of course, those things are really, really expensive. So they want to improve the survival rate for these bombers that they have. So they brought in Abraham Ward and his statistical research group to help them decide where can they put additional armors around those planes so that more of them would survive the attacks. So they analyzed all these different planes that made it back onto the base, and they look at where the planes have suffered the most bullet shots at the time, and intuitively thinking, okay, well, that's where we're going to put more armor, right? Because that's where we got shot the most. But what Abraham noticed was that this whole analysis, this whole study, only applied to planes that actually made it back to the base, whereas the planes that got shut down wasn't included in the study, in the analysis at all. So the bullet holes that they found on the planes actually represents places where the plane can sustain damage and still survive and make it back to the base. So it's actually the places where you don't see bullet holes, that's where those planes that got shot down actually got hit. And that's where you should be putting more armor and more defense on those on your bombers. And that's an example of a survivor bias that I have experienced many times in the way that many of our applications are set up in terms of monitoring and alerting, where we only focus on the things that we can easily identify and know for ahead of time that is definitely caused our application to fail. Instead, I think we should focus more on making our applications easy to debug, even for those failures modes that we didn't know we have ahead of time. And that is where I think the observability is quite different from monitoring. Monitoring, for me, means something like a guard tower where you're watching out for those known failure modes in the system, things like network I/O going up, things like CPU cycle spiking, things like memory usage going up, for example. Whereas observability is much more, I guess, much closer to what a lot of government agencies are doing in terms of collecting lots of metadata about what happens, our communications, who you're talking to, when, so that they can figure out information about what are happening inside the system, but only observing it from afar, hence the name observability. And in control theory, observability is a measure of how well the internal state of a system can be inferred only from the knowledge of external output. So in any given system, we have a bunch of known success, whereby if we're building an API, that means our API returns a 200 response. If we're talking about some application that writes data to a database, the success outcome would be some row gets written to the database. And then there's also the known errors, so our API returning a 500 error where we don't expect them to. So those are the known errors and known success cases, and they're easy to monitor. And those are the things that go really well onto your monitoring, your dashboard, so that everyone can see what's happening in the application. But then there's also things that we know is going to be bad for us, but we don't know how it's going to play out. We know that if we use DynamoDB, that means that when DynamoDB having an issue, it's going to impact us somehow, but we don't necessarily know how it's going to impact in terms of the overall application. Is it going to take down the whole app? Is it going to affect only part of it? And then there's also things that we just don't know we don't know, right? And those are our invisible bullet holes for our metaphorical planes that we should be putting more armors around. And one of the things I keep finding is that teams tend to put a lot of focus and they only alert on those known errors. So we set up all these alerts on a 500 response, but then there's all these other things that can go wrong as well that we can't monitor when we only alert on the known errors. So I think a much better way to set up your alerts is instead focusing on looking for the absence of success signal. So for example, if you're building APIs, you want to monitor the percentage of responses that's not a 200 or 400. And if you're building a message-driven system, say through SQS and SNS, or maybe Kinesis, then you also want to alert on when there's discrepancy between messages that flows from one side of the queue to the other side of the queue, to know that maybe some of the messages are being dropped or not processed successfully. Of course, these alerts only tell you that something is wrong. They're not going to tell you what actually went wrong. And that's where observability comes in, where we need to make our applications easy to debug so that when we do see a situation that we don't know, we can at least figure out what actually went wrong. And in terms of actually implementing observability, the general consensus seems to be that you need to have good monitoring, alerting, visualization, tracing, so a lot of aggregation to build observability into an application. And as we start to build more and more complex systems these days, it's going to be harder for us to figure out what actually went wrong when we get an alert. In general, though, I think the microservices world tooling has been improving, both in terms of the open source offerings, but also in terms of the commercial tools that you can buy and rent these days. There are many of them, and I think they generally do a really good job in terms of helping us make our systems more observable and helping us debug issues, even inside a very complex microservice architecture. But then Amazon threw a curveball into the whole process in 2014 when they announced AWS Lambda, and it became the arrow to the Achilles heel for all these existing tools because so many of them depend on you having an agent installed on a server in order to collect data and publish them. And of course, with Lambda, you don't have access to the server that's running your code, so there's nowhere for you to install those agents. So my name is Yan Cui. I'm an independent consultant and also work part-time as a principal engineer at The Zone. We are a sports streaming platform. We often call ourselves Netflix for sports because we have a very similar business model in that we give you a subscription-based platform to watch any sports we have on the platform. And we even kind of stole the Netflix UI from us as well. I don't know if you can tell. So right now, we have over 40 different sports and 300 different leagues all around the world, and we are available in 8 different countries and over 30 different platforms. And at peak, we see around 1 million concurrent people on our platform watching sports. So for example, the other day, Tottenham played the Ajax. That would have easily have over 1 million people watching at the same time. We have offices in London, Amsterdam, Katowice, as well in Leeds, and we are hiring pretty much across the board in all of those locations. Personally, I've been running workloads in production on AWS since about 2009, and as of last year, AWS also made me one of the AWS community heroes that focuses around the serverless space. And one of the things I found in terms of monitoring and whatnot with serverless is that we already talked about that, okay, now you don't have access to underlying operating systems, so that means there's nowhere for you to install those agents. And these agents, for a very long time, they've done a very crucial job in that and also they've been doing that job outside of your critical path, where we are really concerned about user-facing latency. We don't want those additional latencies for collecting, monitoring, and alerts data to impact our user experience. So these agents, they will collect data in the background, they will batch them up, and then send them off to whatever monitoring system that we actually use. Unfortunately, with Lambda, we also lose the ability to do any form of background processing besides the things that the platform does on our behalf. But you might say, well, that's fine. Another very interesting thing that's changed is that before, when we're running our application inside, say, a container or EC2 instances, we have to manage the concurrency of our application. We write HTTP, we write web applications that can handle, I don't know, 1,000 requests per second on the same server. But with Lambda, one interesting thing that's changed is that the concurrency is now handled by the platform. When we're building API with API Gateway and Lambda, the concurrency is outside of our code. One Lambda function invocation will only handle one request at a time, which means that actually that's pretty good because my code is drastically simplified. I don't have to worry about all this concurrency anymore. But at the same time, we also lose some economy of scale, whereby before all this monitoring data can be aggregated and batched at the instance level. But now, the best we can hope for is batch them on concurrent executions for your Lambda functions, which also means that in terms of concurrency that we send to the downstream system that we actually use to monitor our system, there's a far more concurrency compared to before. This might not be an issue depending on the vendor that you work with, but I've definitely worked with vendors that when you have too much concurrency, they require you to run additional infrastructure in your AWS account to do additional aggregation before you pass those data onto their own backend systems. So with Lambda, we also get higher concurrency when it comes to talking to our own backend systems. You might say, that's fine. You can just use a bigger batch, and then that's the problem solved. Unfortunately, it's also not going to work either. one of the things that people always talk about with Lambda is this whole notion of cold start. When the Lambda platform have to create a new container to run your code, the first time that container runs your code, it takes a bit longer, and that's what we call a cold start. And after that, the same container is reused for subsequent requests as much as possible. And in this case, if you're batching data and in between invocations, and you only send them at the end of that, then there's a good chance that when this new containers have been created, because there's increased traffic to your system, when those additional traffic goes away, those idle containers that hasn't been used for a little while, they are going to get garbage collected by the system, along with any data that you have batched locally, but you haven't sent them out yet. So you also, when you do this, you also have a very good chance, a high chance of losing the monitoring data as well. So you might say, OK, that's fine. In that case, at the end of every invocation, I'm going to send the data straight to my telemetry system. Could be Graphite or whatever. There's another problem with that, however, in that anything you do inside Lambda has to be done as part of your functions invocation, which means if I'm sending data to some backend system, it could be CloudWatch, to record the custom metrics, then that has to be done as part of my functions invocation. And when you're building things like APIs with API Gateway and Lambda, until the whole Lambda invocation is finished, it doesn't respond to API gateways, which means that those additional time you spend to send the metrics and whatnot is going to be user-facing, and your customer is going to have to wait longer for response to come back from your own backend system. So you kind of get stuck in this catch-22 situation, whereby on the one hand, if you are batching data and sending them in a batch, then then you have a chance of losing data. And on the other hand, if you send them eagerly at the end of every invocation, then that additional latency is user-facing. Another trend we notice in the serverless world is that more and more people are now building event-driven architectures, whereby we're finding Lambda invocations being chained together through some form of asynchronous events, such as using SNS, SQS, Kinesis streams, and so on. And of course, trying to trace those core flows that flow through these async event sources is much more difficult compared to if you do it for asynchronous invocations, such as with APIs. So you have two functions on either side of an API call through API gateway, then it's quite easy for me to send those monitoring data across. So those are just some of the challenges that the serverless paradigm, or certainly with AWS Lambda, has introduced us to a lot of tools and practices that we currently have for building observability into applications. But that said, I think it's still it's still pretty straightforward for you to make your serverless application observable, and I argue that it's actually much easier compared to doing the same thing with, say, a containerized application. So starting with logging. You actually get so anytime you write something to console out, that data is captured by the Lambda service and shipped to CloudWatch logs asynchronously without adding any latency to your function invocation. So you get that out of the box, and you also get additional information around a UTC timestamp, request ID, as well as your log message. So you don't have to set up additional configuration on your server and whatnot to do basic log collection, and everything that you collect from your Lambda function standard output is recorded in CloudWatch logs in what is called a log stream. So this is basically one log group. For every Lambda function, there will be a matching log group as well, and inside that, you have all these what is called log streams. Each one corresponds to essentially one container that runs your code. So CloudWatch logs is a pretty easy place in terms of having a staging place to collect all of your logs from all of your functions, but it's not very good for searching. In fact, you can't actually search a particular phrase across all the logs for all of your functions. You have to do them one log group at a time, which of course is not going to work when we're going to have hundreds, if not thousands, of functions running in an environment. So what most people do is that they will go to the CloudWatch logs console, they will pick one of the log groups, and then they're going to say actions, and then you can either stream your logs to the hosted Amazon Elasticsearch service or stream into another Lambda function, and from there, you can just ship all of your logs to whatever log aggregation service that you actually want to use. And that's good news is that you don't have to write this function yourself in terms of if I want to send my logs to logs.io or to Logly. There are actually a lot of applications that's been published by various vendors already to the serverless application repository, whereby you can literally pick one of these guys and then deploy it to your region, and you have a function that you can then subscribe your log groups to that would then ship those logs to, say, Logly or Sumo Logic or whatever you want to use. But the thing to keep in mind here is that CloudWatch Log itself is also an async event source for Lambda. And what that means is that when you have a lot of logs being written and sent to CloudWatch Logs as an async event source, it's going to try to you want to try to invoke Lambda function directly straight away, which means when you've got all this Lambda function running in your region and using a lot of your concurrency, so with Lambda, you have a default regional concurrency limit of 1,000. That's a soft limit. You can raise it via a support ticket. But imagine you have all these functions that are doing business-critical things, and you're spending a lot of concurrency doing those. And all of those functions are also writing logs as well. So they're writing logs that gets pushed to CloudWatch Logs. And if your CloudWatch Logs is then triggering in the Lambda function, then you're going to spend a lot more concurrency just on processing and shipping those logs to to say logs.io or Logly. And that puts you a lot closer to your regional concurrency limit than you may even realize. And the problem is that when you do go over that threshold, that concurrency limit, your function is going to get throttled, but you have no control which function is going to get throttled. So it's just as likely for your business-critical functions to get throttled when that happens as for the function that's shipping logs. So the function that's actually shipping logs may be doing a really low-tier, low-priority feature for your application can cause your business-critical functions to get throttled, which is not a good place to be. One of the things you could do in that case is I can set the concurrency limit on my log shipping function by setting a reserve concurrency on that particular function. That will constrain the amount of concurrency that's used by that particular function. But at the same time, when you do that, you now risk potentially losing data because that function keeps getting throttled whenever CloudWatch Logs is trying to push to that function to ship logs to somewhere else. So when you're running at scale, a much better approach is to instead stream your logs from CloudWatch Logs to a Kinesis stream first, and from there, subscribe another Lambda function to push them to Logly, logs.io, or whatnot. And the reason why this is a better approach is because in terms of concurrency control, between Kinesis and Lambda, there's a one-to-one mapping between the number of shards you have and the number of concurrent executions you have for that particular function. At least, essentially, every shard has got its own dedicated instance of your function, so that when you have a stream that's got 10 shards, then any moment in time, you only have 10 instances of that log shipping function. So that's give you a very good way to control how much concurrency I will spend on this function for my region. And as I mentioned before, every time you create a Lambda function, by default, the system also creates a new log group for you as well. And you really don't want to have a manual process there for someone to have to remember to go to CloudWatch Logs console, click action, and then subscribe to your log shipping function or subscribe to Kinesis stream. So a way to do this, make it automatic, is I actually published a serverless application repository app, which allows you to just, again, you can click a button to deploy to your region, and you can specify the ARN, which can be pointed to a Lambda function or pointed to a Kinesis stream. And this application would use the CloudWatch events, so that anytime a new log group has been created, you would then subscribe that log group to your dedicated ARN. And it also does this in the background as well, so you also pick up any existing log groups that you already have and apply the same change. Another thing to keep in mind about CloudWatch Logs is that by default, the retention policy is to never expire. And this is because AWS doesn't want to delete your logs without your explicit say-so. And that's all well and good, but if you're shipping all of your logs to somewhere else already, where you're paying for storage and processing and network bandwidth, it doesn't really make sense for you to keep paying for having the same data, stay in CloudWatch Logs forever as well, especially when you consider that you are paying something like 3 cents per gigabyte per month. So if you never expire any of your logs, then that particular cost is just going to keep on growing month on month. So again, you can apply the same pattern, and I've got a serverless application repository app that does that for you, that once you deploy to your region, you can configure the number of days that you want to retain those logs for, and again, you'll take care of any log group that gets created in the region, as well as any log group that already existed before you deploy this app. And one of the most important things when it comes to logging and for you to do is to write structured logs. And something that many people seem to have forgot when they move to serverless. I keep looking at the application code that's just going straight console.log, partly because I guess it's so easy now. You don't have to use different loggers, which have given you structured logging as well as creating log files for you so that your monitoring agent can pick them up and ship them off to Logsly.io or whatever you want to use. But now that we don't need those loggers anymore because, well, we are going to write that file, we also seem to have just forgot to use structured logs in our applications as well. Even though it's something that a mistake that many of us made in the past, and we actually learned the lesson the hard way, and we actually know how to do it really well these days. And when it comes to Lambda, it's there's still a lot of value in writing your structured logs so that every time I write a log message, I can get a lot of context around that particular log message as well, including if I'm collecting any correlation IDs through my application. One thing I do find is that many of these loggers I've grown to, I've grown familiar with over the years, they are too heavy an abstraction for me when it comes to Lambda. For starters, while many of them support writing logs to a file and support rolling files and all that, but then again, there's nowhere for me to write those files to, but also what can I do with that file? I need to have some other process to then pick them up and ship them off somewhere, and I don't need to do any of that anymore with Lambda because anything that gets written to send it out will get captured by CloudWatch logs already. So for many of those loggers, they're just too heavy in abstraction for my liking. So what we have done at the Zone is that we've created some very simple libraries which we're trying to open source right now, and including one of those libraries is a very simple logger that just gives me support for structured logging with JSON and give me the ability to change the log level via variables as well, which is very important as we talk about later on how to enable sample logging in our application. So in this case, I can write a log message in my application to say calling API B, and out of the box, the logger will capture a lot of information from the context for my Lambda invocation. But one thing to keep in mind when it comes to thinking about structured logging is that, I mentioned before, with CloudWatch logs, there is a cost to using it. It charges you 50 cents per gigabyte of data that's ingested, but additionally, also 3 cents per gigabyte for data that's been archived in CloudWatch logs as well. And you may think that 50 cents per gigabyte doesn't sound like an awful lot, but when you consider that a 128 meg function, you can actually get 1 million invocations out of that function for just 40 cents. So comparatively, CloudWatch logs is relatively expensive. And actually seen a lot of companies that has end up spending a lot more money on CloudWatch logs than they do on the Lambda functions themselves. And especially when you're writing debug log information all the time and in production, then this can often happen to you. And I've seen a few companies now that end up spending 10 times more on CloudWatch logs compared to Lambda and API Gateway, which of course is not great, especially when most of those debug logs, they don't actually give you a lot of value. So an important lesson to learn is that do not leave debug logging on in production. But those debug logs are also really important. Without them, it makes it harder for us to debug any issues that actually happens in production. And when an issue happens and you know you can fix it, you know what the problem is, if you just had that debug log enabled in the first place, then you end up having to go back, enable the debug logging, redeploy your function, wait for a little while for enough data to come through so that you can actually figure out what the hell actually happened before you fix the problem, disable debug logging, redeploy, and the whole shebang. And when you've got a microservice architecture, even with Lambda, you're still building microservices. A single feature can involve many Lambda functions with different event sources. And if you know there's a problem somewhere along within one of these functions, to actually figure out what the problem is, you're probably going to end up having to enable debug logging and deploy a whole bunch of different functions across different service boundaries, which of course is just going to hugely increase your time to recovery from these issues. So all these initial effort and to redeploy things, to enable debug logging, and to also then disable them afterwards is unnecessary if we just had a handful of logs, a handful of debug logs available to us all times. So a happy compromise between spending way too much money on the keeping and the recording all debug logs and not having any debug logs at all is just sample a small percentage of invocations and record debug logs for those invocations only. I think the standard that we see in the industry is around 1%, where most people would sample debug logs for 1% of their requests. And I guess unless you're Google, where your scale is so big that even when you sample at like 0.01%, you still get enough of a population for debug logs to cover all the different scenarios you come across. And to enable debug logging, one of the things you could do is to use the MIDI middleware. And the middleware, I think, is still a very powerful thing to use in the world of serverless when you're building applications with Lambda. And in the Node.js world, there's a middleware engine called the MIDI, which in this case, I can write a middleware that changes my log level to debug before I run the invocation, my Lambda function code. And in this case, after the function code finishes, regardless of success or failure, I would then roll it back so that the log level would switch back to what it was before. So if in production, I'm logging at an error level for 1% of the invocations, I can then switch the debug level switch the logging level to debug for just that 1% of the invocations. And I can do that because the logger allows me to change the log level dynamically on the fly by changing the environment variable itself. And this is only feasible because, again, as I mentioned earlier, concurrency is now handled by the Lambda platform as opposed to in our code. So I can safely change things like environment variables and global variables without worrying about without worrying about accidentally impacting other concurrency executing request that's on the same container. Whereas with Lambda, one API request comes into API gateway, would just have one invocation, and my function would have the entire container for the duration of processing, or when I process that particular request. In this case, my middleware is really, really simple. I just have a bit of code that says that before I pass the control to the actual function code, I'm going to enable debug logging based on some logic. And once it finishes, I'm going to roll back that decision. And one of the things I also like to do is whenever my function errors, capture the invocation event itself as a part of a special log message so that whenever a function invocation errors, I can always go to the logs to pick up the invocation event, put it on the JSON file locally, and then run my code locally to see what's actually happening, and then put debug points and whatnot to steps through the code. So that's all well and good for individual functions, but as we talked about before, what happens when you've got all these different user transactions that have to span across many different functions? If we just doing deep sample logging individual functions, then you never see the whole picture for any transaction. You're going to see 1% of the logs here that are not correlated with 1% of the 1% that's recorded, that's enabled over there. So really, when you're making those decisions to enable sample logging for sample debug logging, you need to do them at the first function in the whole call chain, and then pass that decision along to all the other functions. And of course, since we're using so many different event sources, some are synchronous, like API gateway, others are asynchronous, like SNS and Kinesis and so on. Those decisions need to be passed along to all these both synchronous and asynchronous event sources. And it should also make it easy for me, or I also want to make it easy for my developers to record additional correlation IDs that they can use to correlate the logs from different functions across different dimensions. So you should be able to record your custom IDs, such as user IDs, order IDs, session ID, and so on. And I need a mechanism that's not intrusive to your development process, but still allow developers to extend it and introduce their own correlation IDs, and it should work consistently across different event sources as well. Again, this is only possible. The approach with token is only possible because we don't have to worry about concurrent requests happening on the same Lambda invocation. So in this case, I can actually store my correlation IDs in a global variable for the duration of that request. And we have a simple library that encapsulates the logic around that lets you store correlation IDs and also fetch them as well, so that my logger, whenever I log something, will all know where to get the correlation IDs from, and then include them in all of my log messages without me having to constantly remember to do that. And of course, we want to make it easy. We can for you to just capture the correlation IDs as it comes into your function. In this case, we also have a middleware that looks at the invocation event before it passes the control over to your function code. And if the event comes in through API gateway, then I know I can find the correlation IDs from the HTTP headers. And the events, if the event is SNS, then I know I can look for the correlation IDs in the message attributes, and same goes to SQS and so on. So I can have a middleware that gets applied to my function that will automatically extract the correlation IDs from the incoming invocation event, make it available to all my logger, so that whenever I log something, they will also be included automatically. And also, whenever I make an outbound request to another HTTP endpoint or to another AWS service, it also then knows how to include them and forward them on as well. So we built a whole set of tools which right now supports API Gateway, SNS, SQS, Kinesis, event sources, but also direct Lambda invocations, as well as step functions, which allows me to have a setup whereby I don't have to constantly remember to do this myself. My logger will just pick up and include correlation IDs whenever they are passed into the function or they be initialized by the middleware. And so long I'm using our wrapper for HTTP module as well as the AWS SDK client, then whenever, say, a request comes in, the first function in the whole code chain is going to initialize the correlation ID using the request ID from the API Gateway event. And then whenever I make a request using our HTTP module, it will then automatically include those correlation IDs as headers, including the decision to whether or not to enable debug logging for the whole code chain along to the next service or the next request. So the function on the other end will also have the same middleware, which will extract those correlation IDs from the headers. Also, the logger will then respect the decision to enable debug logging. And again, the whole thing is only feasible because we don't have to worry about concurrency within the Lambda function. So there's a whole suite of tools that we have built up and which I'm in the process of open sourcing. Hopefully, will be done this week, which basically means anytime you write a Lambda function as part of your the template that we have set up, your functions will have the middlewares enabled that supports the sample logging, but also captures correlation IDs as well. And those correlation IDs that comes in from the incoming events will be automatically recorded inside in the global variables and included in all the logs. But also, whenever you then make a request to say SQS or SNS or to start a Lambda, start a step functions execution, all those correlation IDs will be then forwarded on and made available to the function on the other end of the request. So all of this, in terms of the overhead to developers, is fairly minimal. All you have to remember is just bring in the middleware modules that we have published, and make it easy for you to do the right thing by default. And in terms of monitoring, so let's go a couple minutes. You get some basic telemetry from Lambda out of the box in CloudWatch logs, in CloudWatch, in terms of invocation count, duration, error count, and so on. But as we mentioned before, there's no background processing. So if you want to record custom metrics, you're going to find that you're going to have to spend those additional milliseconds as part of your function's invocation time, which is going to be user-facing when you're building APIs. And you may say, well, that's only 10, 20 milliseconds per API call. It's not that much, but when you've got microservices and you have many core chains that involve multiple functions along the chain, then those 10 to 20 milliseconds can easily start to compound and add up to something a lot more. And Amazon found a few years back that every 100 milliseconds you add to your invocation, to your user-facing latency can reduce sales by as much as 1%. So those additional milliseconds that you spend on sending metrics and monitoring data can actually hurt your revenue if they start to negatively impact your user experience. And one of the workarounds available in this particular space is that since all of our logs are collected, anything that writes send out are collected by CloudWatch logs asynchronously already. So one of the tricks you could do is to actually write your metrics, your custom metrics, as a special format to send it out, so that your function that's picking them up can either filter them out and record them with your monitoring system instead, or if you're writing to everything, if you're using CloudWatch metrics as your primary monitoring system, you can also set up metric filters as well. And this same trick is basically been used by many providers that are specialized for the serverless space. And the trade-off here is that you're adding additional delay to seeing your metrics, but at the same time, you're also adding increasing costs in terms of use of CloudWatch logs as well. But at the same time, you're removing some additional latency that would have been user-facing otherwise. So personally, I think it's a good trick to use when you're building APIs where you're really concerned about those user-facing latency and you try to minimize them as much as possible. But when you're doing background processing, say with SNS and Kinesis and so on, where those additional latency are not user-facing, then you might as well just go straight and publish the metrics to your monitoring system right away. And once you have everything in CloudWatch or whatever you want to use, don't forget to set up dashboard the way we have always done. And if you're using, actually many of the providers nowadays actually support direct integration with AWS. So anything that gets recorded in CloudWatch, in both CloudWatch logs and metrics, gets ingested by the service directly. At least that's the case with Datadog and I think a few other ones I've used as well. And finally, I just want to touch on the tracing as well. So within AWS, you've got an X-ray service that allows you to then see what happens inside your function. And this is especially the case if you're taking the time to instrument your code so that within one Lambda invocation, I can see how much time is spent talking to S3 or how much time into getting data from DynamoDB or to invoke another Lambda endpoint. In this case, it also spans over API gateway as well, so that whenever I make a request to an API endpoint that's backed by API gateway and Lambda, I also see the breakdown for what happens inside that second function in this code chain as well. Additionally, the data that X-Ray collects, they also make it available as a service map view for you to have a quick high-level overview in terms of what different service that your function talks to, as well as in terms of the average latency for those resources. The problem with X-Ray is that it doesn't span over async events, so that as soon as I send a message to SNS or SQS, then I lose the trace for what happens from that point onwards. And also, being an AWS service, it doesn't support other non-AWS services as well. And luckily for us, in this particular space, quite a few vendors are starting to offer a more comprehensive solution that works a lot better as well. One of them is Epsilon. They have a very nice solution that supports both asynchronous as well as synchronous event sources, but they also support non-AWS services as well. And you can also use Epsilon to visualize what's actually happening inside a step function execution as part of that platform. And then there's also Lumigo as well, which lets you monitor your application from the view of a user transaction across many different Lambda functions and event sources. But interestingly, they also give you reporting around the cost, but based on the user transactions as well. So in this case, as a business user, or a product person, I can actually look at this and understand, okay, where's our cost focus on? So before we decide to optimize a piece of code, because the concerns around cost, I can actually figure it out based on the information I get, where those costs are concentrated, so that I can put those optimization efforts towards things that are actually costing me a lot of money. So that's everything I want to cover. So to quickly summarize, a couple of things that are really important to remember when you're trying to build up several applications is that make sure that you're still writing structured logs and that you're instrumenting your code so they can see within X-Ray or other platform that you're using what's actually happening inside your code, so to make it easy for you to debug and deal with any performance issues. And also put some effort into building tools to make it easy for people to do the right thing by default. With that, again, thank you guys very much for your time. If you've got any questions, feel free to ask me now or afterwards as well.
Slido. Let's see if we do have any questions. Look, we have a question. What if I want to log something only if Lambda timeouts?
That's tricky, right? Because what do you do when a function times out itself? So one of the things you could do, and this is something that I've seen that people do this as well, is as part of your middleware, what you could do is you can figure out what's the timeout you actually have for your function, and then you explicitly call before you pass the control over to your handler code, make sure that you time out the handler code itself just before the function gets timed out by the Lambda service, so that you give yourself a fraction of, say, tens of milliseconds to then write something to report that, okay, the function got timed out. That's one of the things you could do. If you're using, I think, Sundra and a few other providers, they also have basically doing something similar, whereby they give you SDK with a wrapper that essentially do the same thing, whereby they time out your function handler code before it gets the whole execution gets timed out by Lambda.
Cool.
Cool.
We were pretty much up for time anyway,
Okay,
so you
right.
did magnificent. Everyone, big round of applause.
Thank you.